Hello, hello testing. 1, 2, 3, 4, 5. Mic check. Done. Hey BreakerSpace, Dev here. We started our journey to make the BreakerSpace by setting up the lights in our first episode. But the audio in that video was all over the place. In this episode, we're gonna fix it. I'll take you through the entire process of what steps are we taking to condition the audio and find out exactly how much improvement does that make. Let's break into it. In our last video, we used an assortment of microphones. And that's what created the sound zoo because each one of those mics works differently. It also didn't help that we set up our studio in a totally new and vacant room as soon as it's paint dried. On top of that, the apartment is really close to the road and it naturally picks up all the noise. Now on the surface, it may look like it's time to buy a new expensive microphone, but worshipping price tag has never been my thing, and that's not why we built the BreakerSpace. Anyone can buy it. I wanna make it. Anyway, before we start, let's take one sample of recording without any conditioning. The quick brown fox jumped over the lazy dog before it all began. Let's hear it back exactly how it was captured without any post-processing. The quick brown fox jumped over the lazy dog before it all began. Now that we have some baseline for comparison, let's go ahead and make some improvements. A large empty room produces a lot of echo. An easy and cheap way to reduce that echo is by covering up the bounce surfaces of the walls and ceiling and floor with something that stops sound waves from bouncing back and forth. That is to say, to absorb its amplitude. There are different ways to go on about all of this, and we'll use a handful of those to give you an idea of how to go on about it. The first kind of sound dampeners we're going to use is called a curtain. No, not any special kind of curtain, the regular good old curtains. The color doesn't matter, but the thickness does, and also the total surface area does. The thicker the curtain and larger the surface area, the better. You will see some faint echo is still there unless all the complementary walls of the room are covered with some kind of sound dampeners. The last of which are usually the floor and the ceiling. So we'll try to cover up some of it, and floor is easier to work with than the ceiling, so we are going to use a carpet. So far, the steps we have taken are not out of the ordinary. For a lived-in room, having curtains and carpets are pretty much the norm, not an exception. But if you want to go deeper into this bottomless pit, then the gradual next step would be to add sound panels. There's absolutely no lack of those over the top of the shelf foam panels, but at the end of the day, they do the exact same thing. If you have your favorites, that's all fine. Just know that whatever you're doing, you are reducing the unwanted sound, not eliminating them. We went with these foam sheets that stick on the wall like wallpapers and make it look like a brick wall. Let me add a coat of paint for color correction, and that's how you end up with this misnomer. For an even better audio performance, it helps to go with a directional cardioid microphone. Omni mics are better for run and gun shooting, where we can't control the directionality of the sound precisely. But controlled A-roll shots and voiceovers, it's better to go with a cardioid mic. By the way, cardioid, omnidirectional, figure 8, these are pickup patterns for microphones. The pickup patterns represent which all directions the mic can record audio from and at what strength. There are plenty more of those names, but cardioid and omnidirectional are the most useful, popular and available ones out there. An omni mic, like this lavalier mic, picks up audio from all directions, whereas the cardioid mic, like this boom mic, picks up audio mostly from the front and its side, and almost none of it from behind it. This effect is achieved by having an array of transducers inside the microphone assembly and selectively summing their outputs constructively or destructively to boost or eliminate a specific sound. Have a look at this video from CNET to understand the concept. Even though the application may seem different, the concept is just the same. But hang in there, isn't this BreakerSpace? Are we just gonna use an off-the-shelf microphone and call it a day? Is this real life? Oh no, we're gonna make some microphones. Just hold on to your... But first, Did you know a speaker is also a microphone? The mechanism by which a transducers work are reversible. So if you have any broken speaker module, just wear them up as a microphone with a TRRS jack and you got yourself the most simple form of microphone. Just check out how it sounds. So now here we have the microphone wired up. As you can see, it is picking up the sound if I knock it with my finger, but it also can pick up the sound of my voice, as you can see the pattern in here. Now you can record it actually by going to a recorder and starting to record as it as a voice. So whatever I'm saying now, I'll put that up
as a recording file, and you can see it in its original quality.
This works because the way audio signals are transformed into air pressure in a speaker, if you apply air pressure, you can get the same signal as output. It won't have the best pickup pattern or the frequency response curve, but if you just want to annoy a sibling or if you have a political agenda that you want to shout out, that will be just fine. Now, let's make something even more fun. This is a DF Robot Fermion module. It uses a MEMS transducer as an audio sensor. It's a turnkey DIY microphone that has all the passive components as well as the power regulator pre-assembled in a neat little package. All you need to do is to just give it some power and connect its output to your recording device's analog audio input. That's it.
Hello testing. 1 2 3 4 5. Mic check. Plosives. Hiss. Done.
Now, this prototype may look a little clunky, but if you are serious about putting together a custom microphone of your own, this is a viable option. There are not many ways to go wrong here. You can do it in 5 minutes flat. And this is what it sounds like compared to our other microphones. Let's have a listen.
To A or not to A? That is the question.
To be or not to be? That is the question. To see or not to see? That is the question. Given their individual sound profile and convenience, I think I'm going to use the lavalier microphone for run and gun shoots and the boom mic for A-roll shots for my other channels, and use the DIY MEMS mic as the voiceover mic of my own. If you want more intricate control of microphone design, that rabbit hole goes way too deep. I really do want to discuss all about it, but my producer is reminding me that this video is about setting up audio for the studio and not get sidetracked by having fun. So instead of rushing through it as a distraction to this video, I've decided to keep it aside as a complete video of its own. Get subscribed so you don't miss it. The steps we have taken so far already gives us a much better quality audio than before. But given the circumstances or the purpose of the audio, it might still be necessary to post-process it, especially for the non-studio and outdoor shots where we can't closely monitor the levels or control the ambient noises. Thankfully, DaVinci Resolve's Fairlight Studio gives more than enough tools to reduce noise, boost dialogue, apply equalizers, limit and compress waveform, etc., even in the free version. The paid studio version also has better AI noise cancellation, among other pro features, but I have decided not to buy the studio license until I have at least 1000 subscribers. Plus, there are other ways to achieve AI noise cancellation, like using NVIDIA Broadcast or Crisp while recording, or using AI noise removal tool like Focal Removal, Auto, and the likes on a pre-recorded audio file. Adobe has a free tool as well, but I just can't be asked to use it. With all that said and done, it's time to compare the progress we have made so far. Let's do a test record on our new setup. The quick brown fox jumped over the lazy dog at the very end. The quick brown fox jumped over the lazy dog at the very end. And here's the one from before. The quick brown fox jumped over the lazy dog before it all began. And after. The quick brown fox jumped over the lazy dog at the very end. Well, we have come a long way. Look, I'm not planning to over-engineer my audio anytime soon. I just want to keep it acceptable and not be annoying. Because audio is one of those things, when it goes bad, it takes the whole video down with it. and I just want to stay safely above that level. I hope we have achieved that, but what do you think? Let me know in the comments. Press like if you liked it, dislike if you disliked it, share it with anyone who you think might be interested in audio, DIY, microphone, etc. Get subscribed for more videos like this and come along on a journey on the making of BreakerSpace. And yeah, go watch that video where we made this DIY studio lights in case you missed it.
Baba black sheep having wool. Yes sir, 3 blacks full.
Hello, 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 hello. Bambabil, bambarim, bamber, bamber. Hey! This needs to be my mobile soundtrack.